Hey everyone, so recently I posted a photo about students using base 10 blocks to create area models for 2-digit by 2-digit multiplication. And I just wanted to quickly go over that process for anyone who maybe wanted some more details about how to use those base 10 blocks for that 2-digit by 2-digit multiplication. So with these base 10 blocks, students would create their factors. So let's say that we were multiplying 13 times 14, okay? Students would create a rectangle using the 13 and 14 as their length and width, okay? It does not matter which one, goes down and which one goes across. Either factor, because of the commutative property, can go on either side. So I'm just gonna do 13 going down, and students may also see this like with grid paper would be great for them to count down 10 and then 3 more to see that that's 13. And I always have my students label it, because when they move into drawing their area models and doing open area models, then they're prepared to label it correctly. Okay, so we have 13 going down. This is going to represent how many rows there are, and there are going to be 13 rows of 14. Okay, so that's 10 and then 4 ones. Okay, is the random yellow one here bothering anybody else or just me? Okay, so we have 13 and then 14, 10 plus 4. All right, because 13 is a 10 and 3 ones, and 14 is a 10 and 4 ones. So this right here, it shows 13 rows of 14, okay? So basically students are gonna be to find the product, they're finding the area of this rectangle, okay? How many square units would fill this rectangle? So students would do 10 rows of 10, and as students build 10 rows of 10, most of them would already know this. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If they did 10 rows of 10, they see that that is 100, okay? So instead of using the 10 rows of 10, they could just use a 100s flat, okay? All right, then they can move on to 10 rows of 4 or 3 rows of 10, doesn't matter the order, okay? So I'm just gonna go ahead, this is 3 rows of 10. Okay, and then we're gonna have 4 columns of 10 or 10 rows of 4. Okay, and then here we're gonna have 3 rows of 4. Okay, so there's 1 row of 4. 2 rows of 4. And then 3 rows of 4. All right, so this helps students see those partial products. So 10 rows of 10, or 10 times 10, is 100. Okay, and then they have 10 rows of 4 here, okay, which is 40. 3 rows of 10, 30, and then 3 rows of 4, 12. And these are their partial products, okay? So when they add that together, they get 182 as their final product, okay? And so students move from building, so like you wouldn't do this with extremely large numbers. You would start simple with smaller numbers, and then once they understand the concept of the area model being used for 2-digit by 2-digit multiplication, then they'd be ready to move into drawing an area model, what we call an open area model, where it's not using the base 10 blocks, okay? So like 10 plus 3, this also helps them see the proportions, like that 10 represents a much larger amount than the 3, okay? And then that 14 would be a little bit larger as well than the 13 side. Okay, so they can draw their area model, and then they would represent their partial products. 10 times 10 is 100, 10 times 4, 40, 3 times 10 is 30, and 3 times 4 is 12. And then they would be able to take their partial products and add them together to get their product of 13 times 14. So this kind of just shows how that area model works and how to use the base 10 blocks to really help students conceptually understand why they can do this area model, why it works to find their product.